Okay, so this afternoon we're going to continue our discussion of bisection method, and you're going to look at this example number 2, similar to what we had to do with the other first example, except in this case there's a slight difference. We have got a trigonometric angle which is involved. In this case, the angle we have is our cosine here. So before we, the question reads, before we find the root of the equation f of x equals to cos x minus x plus 1 equals to 0. With the bisection method starting with the interval 0 to 3. Okay. And how does our function f of x look like in this case? So if you go down a bit here in our notes, we are going to find our function f of x equals to cos x minus x plus 1. Now this graph is showing the function between -1 and 4. So basically this is how our function behaves between -1 and 4. So our interest is between 0 here, this point, and 3, which is that point. And from the graph, as we can clearly see, f of x equals to 0. The 0 is here. We can see that our function cuts the x-axis some point there. So by using this graph, we can see that actually there is a solution to this particular function. And we made the assumption that the kind of functions we're going to be looking at in this course, especially in this chapter, are functions which are going to be single valued. They are going to have a single value in the interval we are interested in, and this graph shows that. The other assumption we made was that our functions are going to have real roots, and of course this is a root which is between somewhere 1 and 2, as can be seen from the graph. So how do we proceed? The one thing I want to mention is that when you are dealing, like in this case, we are interested in the interval 0 and 3. When you are dealing with trigonometric functions, your trigonometric functions will not be accepting, you will not be using degrees. So your trigonometric functions will not accept angles in degrees, but they will accept angles in radians. And for example, pi is a number in radians which is equal to 3.14, something like that. So you actually have to give your cosine function, as you're going to see, you're going to give it actual numbers, and those numbers have got units of radians. So if you notice that your function has got a trigonometric function, you have to go on your calculator and you have to set your calculator so that it accepts angles in radians and not degrees. Is this clear? You have to go on your calculator, then you set your calculator to accept angles in radians and not degrees. Are we clear?
Yes, clear.
Do we know how to do that with our calculators? Now this is something which I can't teach, because people have got all sorts of different calculators. But in my case, I've got a Casio calculator. So what you do is you press on the mode button the first time, you press the mode button again the second time, then it's going to display degree. Then under degree there's a number 1, then rad, there's a number 2 under rad, then there's grad, there's a number 3. Those are the buttons you're supposed to supposed to enter or type or press, so that you can choose what kind of units you want your calculator to use for angles. So in this case, because you're interested in radians, I'll press 2. When I press 2, then on the display of the calculator, you see an arrow. If your calculator is accepting angles in degrees, on the display of your calculator, you should see a D for degrees. But in this case, since I've set my calculator to accept angles in radians, you should see an arrow. So this is something which you should be able to do. Are we clear? This is something that should be done when you're dealing with your trigonometric angles. Okay, so let's get started. So we have the interval 0, 3, then our interval 0,3. So we usually denote our brackets as a and b. Open bracket a, then b, then close bracket like that. So in this case, this bracket a b is what is the bracket which you have as 0,3. So in this case, if we do that, then you see that your a is equals to 0 and your b is equals to 3. Is that clear? So after setting your
Yes,
a
sir.
to 0 and your b to 3, the next thing you have to do is you need to find out what is the value of this function which you have, f of x equals to cos x minus 1 plus 0. What is the value of this function at a, and what is the value of the function at b? The only thing you see from the graph, if you look at the graph, what you see from the graph is that the value of the function at 0 is somewhere close to 2, but maybe it's not exactly 2. And the value of the function at 3 is somewhere close to minus 3. So the graph gives you some rough idea, but you actually have to work out what the value of the function is at this particular point. So we have to evaluate f of a. So we find out what the function is at a, and we also have to evaluate f of b. So in this case, f of a is going to be equal to f of 0. Then, hoping at this particular point, you have set your calculator to accept angles in radians. So that's going to be cos 0 minus 0 plus 1. And cos 0 is basically 1. 1 minus 0 plus 1, that should give you 2. So f of 0 is 2. As you can see, this 2 is a positive number, so it's greater than 0. So your function at f of 0 is positive. Next, you have to work out f of b. So f of b is going to be equal to f of 3, which is going to be cos 3 minus 3 plus 1. This cos 3 minus 3 plus 1 is going to be minus 2.989992497. The point here is that this number is negative. That's the thing you're supposed to take from there, that f of b is negative and f of a is positive. So after finding out that f of a is positive and f of b is negative, what we are trying to do here is we want to find out if there is a root which exists in our bracket 0,3. We want to find out if an answer exists in this bracket 0,3. And how do we do that? We work out this product, f of a times f of b. Now, when we work out this product, f of a times f of b, if this product, f of a times f of b, if the product, when you multiply f of a, the value of f of a and the value of f of b, when you multiply them, and you get a product which is greater than 0, that means that there is no root in the bracket you have chosen 0,3. This is a step which always has to be done. If you are given a bracket 0,3, you always have to make sure that in that particular bracket you've been given, there is actually an answer. There's a root there. If the product f of a times f of b, you multiply your product and you get a negative, then it means that a root exists in this particular bracket 0,3. Basically, what it means is that your function has crossed the x-axis. It has changed from being a positive function and it has moved to being a negative function. Or your function has changed from being a negative valued function, it has moved to being and it has crossed the x-axis, now it's positive valued. In our case here, with the help of this graph, we can see that somewhere here at f of a, which is equal to f of 0, our function is 2, so it's positive, and at f of b, which is 3, our function is negative. So in this bracket, our function has crossed the x-axis. Like that. So when you multiply f of a times f of b, that's going to be, for f of a, we have got 2. That's what you have. When we worked it out here. F of a, the value of f of a is 2. Like that. Then at f of b, The value of f of b is, this is what you have there, that's minus 2.989992497. So you've got 2 multiplied by this number here. You've got a positive number multiplied by a negative number. When you do that, you're going to get minus 5.979984,993. This is a negative number. Since this number is negative, it shows you that it's less than 0. And from what we have here, we have, if the product is less than 0, then it shows that there is a root which exists in that bracket. So since our product f of a times f of b is negative, it shows that a root exists in our bracket 0,3. So basically, the negative sign is trying to show you that our function f of x has changed sign. In our case, it has moved from positive to negative, and it has cut the x-axis somewhere between 0 and 3. Is that clear?
Yes, it is clear.
You always have to check when you're given a bracket. You always have to check and see if there is a solution in this particular bracket which have been given. If there is no solution in that particular bracket you've been given, if the function doesn't cut in between the bracket, it doesn't matter how many times you're going to shrink the bracket, you will never find an answer. So it's always very, very important that you check that there is a solution in the bracket. Luckily, since now it's easier to make graphs, like you have seen in your exam and also in your test, we're going to provide you a graph. We're going to give you a graph of the function which you're supposed to be working out, so that you are convinced that there is actually a solution, and we want you to find what the solution is. Okay. So now that we have convinced ourselves that the solution exists between 0 and 3, the next thing we have to do is to find the root. And we do this by guessing.
I want to ask.
Yes.
Like, how can one do the shrinking process, like the way we are coming up with this? Now, when you are using
when you're what?
When you are coding.
When you're coding.
Yes. How do you go about these steps?
You can do these steps. These steps can be done because, as you're going to see, they are repetitive. But one of the good things which is the reason why we chose Python is that actually you have got programs which already do this. Is that clear? The reason why we chose Python is because Python has got modules which actually already do this. So it's actually right now, as things stand, it's not necessary for you to write a bisection program because that program already exists. And with Python, if some program already exists somewhere there, we have learned how to import a module. So you just import that module. Then after you import the module, you look at what's in that module, which function is doing the bisection. Then you look for help on that particular function. You see how the bisection is supposed to be done. That's all.
Yeah, so that's where my question was coming from. Like how to show all the process that you have been doing.
You can do the process. I think it's possible for you to physically do the process which we've been doing. There is a code somewhere, as I'm going to show you later on. Okay, probably sometime next week. There is a code you can write on your own which does bisection. But like I've said, the reason why I taught people modules and how to import stuff is so that people do not have to do something which is already there. But if you want to do it for practice, that's fine. You can redo the code. There's already a code somewhere in one of the nodes, which are on Moodle. If you have looked at the notes for the previous class for last year, you should be in one of the notebooks. There should be a code somewhere there. But of course, I'm retyping things. So again, we're going to show you that. But if there is already, like in this course, if there is already a piece of code which does that, we are going to use that. The reason is we want to show you, we want you to have an idea of what the code is actually doing than just you using code. So you physically do it with pen and paper. Then after you see how it's done with pen and paper, you understand, then you can use these algorithms which are already there. Okay? Yeah, people have been trying to do these things for a very, very long time. From the 80s, people have been trying to develop programs, and those programs which work out these bisections and everything things are very good these days. So unless you want to redo something from scratch, again reinventing the wheel, which is something which I don't encourage, I want you to learn how to use stuff which is already there. Once you learn how to use something which is already there, then if something is not there, then you can build it yourself, or you can develop the code yourself. Are we clear?
Yes, sir.
Okay. So the next thing we do is we guess what the solution is supposed to be. And what we use as our guess solution is what's referred to as a midpoint, which is denoted as C. So the midpoint is found by adding the lower boundary A and B. So A plus B, we add them, then we divide by half. So in this case, our A is 0, our B is C. So when you add A plus B like that, then you divide by half, we're going to get a midpoint. So substituting our current values of A equals to 0 and B equals to 3. So we want to get a midpoint. So C is going to be equals to half 0 plus 3. 0 plus 3 is 3. So that's going to be C equals to half 3. Then 3 divided by half, you're going to get a midpoint as 1.5. Are we clear? So our 1.5 in this case is somewhere in the middle here. Somewhere there. Halfway between 1 and 2. That's going to be your midpoint. This is what you have guessed as your first solution. Is it correct that it's the answer? Maybe no, but it's better. It's somewhere close to what the answer is supposed to be. Okay. So after working out the midpoint, C equals to 1.5, the next thing we want to do is we want to find out what is the value of our function f of x at C. So you will find out fc, which is equal to f of 1.5. Now fc, which is equal to f of 1.5, is going to be equal to cos 1.5 minus 1.5 plus 1, which is negative 0.429262,978. So our function at the midpoint is negative. That's what it shows. Here, as you can see, midpoint is somewhere here. So at that particular point, our function is negative. Is it clear?
Yes, sir.
Yeah. So after finding out that our function is negative at this particular midpoint, the next thing you want to do is you ask yourself a question. Is there a solution? Is there a root between 0 and the midpoint? Does the function cross the x-axis between 0 and the midpoint, which is here? Does it do that?
It does.
It does. So how do you find out that if your function has crossed the midpoint? So you work out next. We check if a root exists between A and B. And how do you do this? How do you carry out this check? You work out this product, f of A times f of C. So you multiply the value of the function at A times the value of the function at C. When we are doing a multiplication, as we have seen at the beginning, when you multiply the value of a function at certain numbers, if the product is positive, it means that the function has not crossed the x-axis. There is no root. If the product is negative, it means that the function has crossed the x-axis. So the root exists. So in this case, our f of A, which is 0, and f of A being 0 and f of c, c being 1.5. So at f of a, our f of a is from what we started with here. F of a, here it is, f of a is 2, and our f of c, which you have just found out here, f of c is this one here, minus 0.429262,978. So we multiply 2 times minus 0.429262,978. So we are multiplying a positive number times a negative number. When you multiply a positive number times a negative number, what you get is a negative number. In this case, our negative number is minus 0.858525956, which is less than 0. So this product being negative shows that there is an answer, or there is a root which exists between A and C. Are we clear? Between A and C. So A is here, A is equals to 0, C is 1.5, which is this side. But between C and B, there's nothing. If f of A times f of C is negative, it means that between C and B, there's nothing this side. There's no answer between C and B. Is that clear? Is it clear?
Yes, sir.
So, if between C and B there is nothing, then we make C become B so that we can shrink our bracket. So in this case, we make our C, which is 1.5, we make our C become B, and we make our f of C, which is equal to minus 0.429262,978, we make that become our f of B. Are we clear?
Yes, sir.
So with this, our bracket now shrinks. The bracket has now shrunk to AB, which is equal to 0.1.5. Our A is 0, our B is now 1.5. With this new bracket, we use this new bracket to work out a new midpoint, a new C, using our old A, which is 0, and our new B, which is 1.5. So we work out C. C is going to be equal to half A plus B, and that's going to be equal to C equals to half 0 plus 1.5. That will be C equals to half 1.5. So we end up with C, which is equal to 0.75. So our C is now 0.75. 0.75 is, if you look at our graph here, 0.75. This is 1. So half of that is this side. This is 1.5, somewhere here, 1.5. So 0.75, it should be somewhere here, somewhere there. So this is where our midpoint is, 0.75. Are we clear?
Yes, sir.
So with this new midpoint at 0.75, we need to find what is the value of the function at the midpoint, which is 0.75. As you can see here, the function is positive at this midpoint. So we work out the precise value of the function, then we find out if there is a solution between A and C here. As you can see, there's nothing, but we have to do this physically. We can see, yes, there's nothing, but we have to do this because the function doesn't cut anywhere in between A and C. So that's the next thing we have to do. So we work out the precise value of the function at C. So f of C is equal to f of 0.75. So that's going to be f of C equals to f of 0.75, which is equal to cos 0.75 minus 0.75 plus 1, which is equal to 0.981688868. So this is a positive value. So at f of C, our function has a positive value. So after finding out that the function has got a positive value, we check if there is a root which exists between A and C. As we have seen from the graph, there is nothing. The reason why there is nothing is because when we work out this product f of a times f of c, so in this case f of a, with f of a, the value of f of a is 2, the function at 0 is 2, and the value of f of c is what we have just worked out here. This is also a positive, so you end up with 2 times this value here, which is that. You multiply these two, you end up with 1.963733,789. This number is positive. Since the product f of a times f of c is positive, then it means that there is no solution between a and c. So if there is no solution between a and c, so our c is here. So our c is 0.75, somewhere here. And our a is here. Then we make our a, we make the c become the new a. So always it's the c becoming the new b, or the c becoming the new a. So in this case, since between a and c there is no solution there, we make our c become the new a. Is that clear?
It's clear.
So when c becomes a new a, we end up having a which is equal to 0.75 and a b which is equal to 1.5. So in that case, in that way, our bracket is going to shrink. So our c, which is equal to 0.75, will become our new a, and our f of c, which is equal to 0.981688868, will become our new f of a. So in this case, our bracket AB is going to shrink. It's going to become 0.75 and 1.5. So our bracket has shrunk, this side and this side. Next, with this new bracket, we have to work out a new midpoint, a new solution. C, using our new A 0.75 and our old B 1.5. So our C is going to be equal to half A plus B. That's going to be C is equal to half 0.75 plus 1.5. That's going to be 0.75 plus 1.5. That's going to give you 2.25. Then divided by half, you end up with C equals to 1.125. This is going to be a new C, a new midpoint. With this new midpoint, you want to find out what is the value of the function at this new midpoint. So that's going to be f of c, which is equal to f of 1.125. So, and that's going to be cos 1.125 minus 1.125 plus 1. That's going to give you 0.306176516. This. So what you see here is that the function at this new midpoint of 1.125 is positive. So you now check, what is there a solution between your A and your new midpoint by working out this product f of A times f of c. So f of A multiplied by f of c, like this. So f of A is this one. Your f of A, if you remember, you just made f of A up here. F of A, that's your f of A, that's your 0.981688863. That's your f of A, and your f of c is this one which you have here, 0.306176,516, like that. So in this case, that's positive and positive. So f of A times f of c, this is a positive value function. At f of A, the function is positive. At f of c, the function is positive. You multiply these guys, you end up with 0.300570077. This is positive. So f of A times f of c is a positive product which is greater than 0. Now if the product is greater than 0 between f of A and f of c, it means that there is no root between A and C. Is that clear?
Yes, sir.
1.125. 1.125. Where is 1.125? Somewhere here. 1.1 somewhere here. Somewhere there. somewhere near there, somewhere there. So there is no root between A and C. If there is no root between A and C, then the C which you have, which is 1.125, you make that C become A. So our C, which is 1.125, we make this C become A, and our f of C, which is equal to 0.306178,151, we make this become our new f of A, like that. So with this, our bracket is going to shrink. It's not going to be AB, that's going to be 1.125 to 1.5, like this. So this is going to be our new bracket. So we are shrinking the brackets after every step of estimating a new midpoint. Next, we work out a new midpoint C based on this new bracket which we have. So we have got a new A, which is 1.125, and you've got a old B, which is 1.5. That. So C is going to be half A plus B. That's going to be C equals to half 1.125 plus 1.5. So that's going to be C equals to half 2. This bit, you add this stuff inside here, you end up with 2.625. Then you divide this by half, you end up with C equals to 1.3125. So this is going to be your new midpoint. With this midpoint, next you want to find out what is the value of the function at the midpoint. What is the value of the function at the midpoint? So in this case, you have to work out f of C, which is equal to f of 1.3125. So that's going to be cos 1.3125 minus 1.3125 plus 1. This is going to give you a minus 0.05700066233. So as you can see, at this new midpoint now, the function is negative, meaning that at this new midpoint, the function has crossed the x-axis. So with this thing in mind, we want to find out if between the A which we have and this midpoint, the function has crossed the x-axis. So work out this product, f of A times f of C. So in that case, f of A times f of C is going to be f of A is our A is 1.125, and f of A is this 0.306176,516. That's our f of A. Then our C, f of C, our f of C is what we have here. This is our f of C. So when we multiply this, which is positive, multiplied by some number which is negative, we end up with minus 0.017472234. This is negative, which is less than 0. So this shows, if we got a product which is negative like this, it shows us that there is a root between A and C. So if there is a root between A and C is our midpoint, then it means that between C and B, there's nothing. Then it means that between C and B, there is nothing there. So what we are going to do next is we are going to make our midpoint C equals to 1.3125 become our B, our new B, and the value of the function of the midpoint f of C, which is equal to minus 0.057066 is going to become our new f of B. So when you do that, our bracket AB is now going to shrink. It's going to become 1.125, 1.3125. This is going to be our new bracket. Are we clear? So our bracket is getting smaller and smaller, while making sure that whatever is there in this particular bracket is something which is going to hug the solution or the root to this particular function. Are we clear? Hello? Is it clear? we work out a midpoint C based on our old A, which is equal to 1.125, and our new B, which is equal to 1.3125. So we end up with C equals to half A plus B. So that's going to be half 1.125, which is what we have this side, plus 1.3125. That's going to be C equals to half 2.4375. 2.4375 divided by half, that's going to give you 1.21875. So this is going to be your new midpoint. Are we clear?
Yes, sir.
So next, we want to find out what is the value of our function at this new midpoint. So we have to work out f of c, which is equal to f of 1.121875. So next, so for us to do that, so it's going to be f of 1.12875. That's going to be cos 1.12875 minus 1.21875 plus 1. So we end up with 0.126249,318. So this is positive here. So the next question we ask ourselves is that, is there a solution between A and C? So in our case, we know A is our A is what we have here. This is our A, 1.125. So what's the value of this function at A at 1.125? The value of the function at 1.125, which is this, is this. So this is a value of a function at A. As you can see, it's positive. So we so here, so here f of A, this is what you have here, and f of C, that's what we've just worked out here, it's also positive. So we multiply a positive number times a positive number, we end up with 0.038654586. This is the positive, which is greater than 0. So what does this show? It shows that between A and C there is no solution, since our product f of A times f of C is positive. So if the root does not exist between A and C, then we can make our C, which is the midpoint, this midpoint, we can make our C, which is the midpoint, we can make it become A. So our C, which is equal to 1.21875, we can make this C become a midpoint A. So sorry, our C, midpoint C, we can make it become A. And the value of the function at the midpoint C, which is 0.126249351, we can make that become our f of A. So in that case, we end up with a midpoint, we end up with a bracket AB, which is equal to 1.21875 and 1.3125. Right now where we are, as you can see, I think the bracket is sufficiently small. So now that you've got a bracket which is sufficiently small, we work out a final midpoint between these A and B. So we use our A, which is 1.21875, and our odd B, which is equal to 1.3125. We use these two values to work out a final midpoint, which is going to be our final approximation of what the answer or what the root is supposed to be. So C is going to be equal to half A plus B. That's going to be C equals to half 1.21875 plus 1.3124. Like that. So you add those, you end up with 2.53125. Divide by 2, you end up with C equals to 1.265625. So this is going to be your midpoint, and this midpoint is going to be your final. That's what you're going to take as your final answer. If you still want to squeeze the bracket again, that's up to you, but I think I'm happy with this because I think the bracket is sufficiently small. Okay, next you want to find out what is the value of your function at this midpoint, because remember your roots or your 0 is a value of x which is going to make your function at that particular value become 0. Okay, but with what we are doing, it's not possible for our function f of x to become 0. The only thing we can do is to find the value of x which makes f of x approximately become equals to 0. So in our case, when we check with this midpoint which we have as our root, we check what is the value of this particular the function at this particular value. So we end up with cos 1.265 625 minus 1.265 625 plus 1, we end up with 0.034 83158. So this is what we end up with. It is not equals to 0 because these bisection things, these are approximation methods. It is not equals to 0, but it is approximately equals to 0. Are we clear?
Yes, sir.
Bisection these numerical methods, they approximate a root. So in this case, we take our root to be 1.265652. So this is going to be our root. Now, the thing I want to mention about these bisection things is that, as you can see, we have been doing this for an hour. You can do these things squeezing the brackets so many times, okay? And also, it's not that you're always going to choose a bracket which is maybe very small. Sometimes people start with a bracket which is larger, okay? But it's always important also, once based on what you have chosen as a bracket and what you think the tolerance is supposed to be, how small you, like tolerance as in you want to stop doing this bisection when the bracket is how small. So based on what you want the tolerance to be and the bracket, the size of the bracket you have started with, it is always possible to make an estimate of how many times you should do a bisection method. So that is what you're going to look at next week. And also we'll introduce you to other methods, so open methods. So in this case, for this particular course, we are only looking at one bisection method, one bracketing method, which is the bisection. We are also only going to look at two open methods, something called Newton-Raphson method and something called the second method. There are other methods, I think, since I'm the one teaching the computational courses now. The other methods, again, probably we'll introduce them in fourth year because we can't take the whole course just teaching these methods for finding. We have to do other things. So we'll always be picking some things which we can teach now, then other things which can't be taught now, we'll push them to the other course which we're going to do in fourth year. So basically, this is where we come to the end. Any questions for today? Are there any questions?
No questions on my part.
Okay, so if you've got no questions, we'll see you next week.
Alright, thank you, sir.
Okay.